For Chapter 8, your worksheet looks like this. Okay. What I would like you to do, you're actually not going to turn this in, but you will want to turn it in your notebook for the notebook check. But hopefully this will be kind of a one-page summary of what Chapter 8 is all about. So what I'd like you to do in order to fill this out is on the periodic table picture that it's given you, I would like you to draw the trend of each of the characteristics, so effective nuclear charge, atomic radius, ionic radius, so on and so forth. Write the trend going from left to right when it's increasing, or right to left if it increases that way. Also write your trend going down a column. So what happens when you go down? Does it increase or go up increase? Make it so that you can see all of the trends on this one page. On the right-hand side of your space, what I want you to do is very briefly, don't write paragraphs, just use specific keywords, describe why the trend is the way it is. Okay, make this sheet work for you so that it's kind of a one-page reference, so you can just glance at this picture to understand the trend, glance at your explanations to understand that trend, okay, why it is the way it is. So for the next video, well, couple videos, we're going to go through each of these trends, describe what they are, and basically give you all the information that you need to fill out your Chapter 8 worksheet. Okay, again, I won't have you turn it in at the beginning of the chapter just because we're so crammed at the end of this quarter, but I will be looking for this when I grade your notebooks at exam time. All right. So, first section in Chapter 8 talks about the development of the periodic table. I, as the good instructor, have already told you about my fascination with Mendeleev. We've already talked about him extensively and what he's done for the periodic table. Okay, his concepts led us to what we know today, or at least led us to be able to explore what we know today. Hopefully what you got from our last video for Chapter 7 was that our shape of the periodic table helps us in understanding where the electrons are. Now, Chapter 7 focuses on all of the electrons on our atom. Now what we want to focus on are the outermost electrons. Okay, these are called the valence electrons. They're the outermost electrons, and we're interested in these because these are the electrons that do the chemistry. They are the electrons that are available to interact with other valence electrons, other outermost electrons, and that's how bonding occurs, and that's how our chemical reactions ultimately happen. So we've already actually defined a way that we look at our outermost electrons, and that's looking at the condensed versions or the abbreviated versions of our electron configurations. So if we look at, say, group 1A elements, we have hydrogen and then lithium, sodium, potassium, so on and so forth. We'll just cut it off there. Hydrogen, it doesn't have a condensed electron configuration, it just has its electron configuration. We have 1s1. Lithium is going to be just like helium plus 2s1. Sodium, just like neon, 3s1. Potassium is just like argon, plus one additional electron in the 4s1. These are the valence electrons. In the condensed version, that abbreviated electron configuration, the electrons that we don't put in with our noble gas configurations, these are the valence electrons. These are the outermost electrons. And one thing you'll notice is that group 1A, all of the elements in group 1A have one valence electron. So elements in the same group are going to have the same reactivity because they have the same number of valence electrons. If you haven't noticed, the shorthand I use for valence electrons is V dot E with a negative sign dot. So if they have the same number of valence electrons, and the electrons are the things, the valence electrons are the things that do chemistry, that's why they have similar reactivity. So what I mean by that is, if you think about it, in hydrogen, lithium, sodium, and potassium, what ion do all of these elements typically take? Well, group 1A, we learned way back in chapter 3, usually form a +1 cation. And that is from losing or donating their one valence electron. That is why everything in group 1A had a +1 charge, was they had one valence electron. They are willing to give it up so that they can be just like the neon gases, which are very, very stable. All right, so that was a little side note going back into chapter 3. Now you can look at the periodic table. If you look back at chapter 3, look at all of the charges that you memorized, okay, and look at their valence electrons, and you'll start to kind of see and make sense why they took the charges that they took on. All right, in the next video we will talk about our different periodic trends and what they mean for us.